Hey everybody, Alex from cnc-o-rama here, and I'm going to talk to you about G-codes for CNC mills. So there's also G-codes for CNC lathes, which are very similar, but there's enough differences that this series of videos is going to focus purely on mill. So why would you want to learn G-code? One is maybe you don't want to buy CAM software. So CAM software is a tool that helps you generate G-code related to CAD software, and you can pick geometry off of a model, and it'll help you generate G-code with that. Some people just don't want to buy it, and the parts are simple enough that they can type the code by hand and make those parts. So that's one option. The other thing is, if you are using CAM software, knowing the G-code helps you troubleshoot your program. So maybe you're to the point where you're making successful parts and they're turning out well, but when you generate that G-code, it looks completely foreign to you, and you would just like to better understand that G-code so that you can better manipulate that CAM software to generate what you're trying to do, basically. All right, so with that said, I have a list of a lot of common G-codes. So there's definitely more G-codes than this, but these are the ones that I think beginners should be learning. And once you know these G-codes, usually it's a lot easier to just look at a new G-code and do a web search on it and figure out what it means. So you'll notice these G-codes are separated into groups here. And we'll talk about what those groups mean in one of these videos in this series. And then there's also these M codes. So as we get through this series, we're going to look at some programs and build some programs ourselves, and we'll see how these M codes get incorporated too. All right, so to get started, let's look at this. So this is ncviewer.com. And you can come here and check this out. So basically, you type your G-code in here, and it's going to plot it for you over here. So this is using, as most CNC milling does, it's using the Cartesian coordinate system. And you may remember that from like high school math classes where you're plotting points in your X and Y. So this has the X and Y on this plane here. And then, so X is the red, Y is the green, and maybe it's hard to even see that on the screen here. And then blue is your Z. So that's pretty common if you look at different CAD programs. When it shows your coordinates, those red, green, and blue are X, Y, and Z. All right, so as I'm navigating this, to do this orbit that I'm doing, I'm holding down the scroll button on my mouse. You can also do it, let's see. So you can zoom in with the scroll button, zoom in and out with the scroll wheel. I'm also, if you click your right button, you can zoom in and out by moving the mouse up and down. And then your left button allows you to pan. So if you want to go normal to a face, which in most cases we do, we want to be looking at the XY. I'm going to come up to this block up here and click that top face. So now I have my X and my Y I'm looking down at. And that's what we're interested in for most mill programming. So let's look at this. So we have a G0. So that's the first code we want to talk about. So I said G0, there's G00 shown here. But on most machines, you can drop off that leading 0, so it's just G0. So either one works, G00 or G0. And this is a rapid traverse. So rapid traverse is for pre-positioning moves. You should never be cutting material in a rapid. So let's just get started. So let's click over here. I have my caps lock on. So generally G code is all going to be uppercase. That's why I have caps lock turned on. And then G0, I've seen a lot of first timers, instead of G0, they'll type GO, which looks very similar, but it's not GO, it's G0. So that's a really common mistake to look for if your code's not working right. So let's do a G0 to X0, Y0. And you can see I put some spaces in here. These are just make it easier to read. You actually can, the code will run just fine if you don't have the spaces. So when we're starting a new program, we usually assume that we're starting from home position, which is like all the way retracted in the Z and then kind of at some corner of the machine in X and Y. So that's why I like to first move to some starting point before I come down in Z. So I can do another G0 to Z0. And in a real program, I might not go exactly to that point. I'm just kind of illustrating this to get you guys started. So these are all rapid movements. These are as fast as the machine can travel to these locations. So maybe let's just, for illustration purposes, do a few more. So I'll do G0 to X5, G0 to, oops, Y -3, and then G0 to X0, Y0. If I click plot, it'll show this for me. It didn't show where we came down, but I think that's because that was from some unknown location. But we did generate a triangle here. Hopefully you guys can see that. Pretty vague. See, these are these black points here show that triangle, and then there's some vague lines in between them. So let's see. You'll notice some things I did here. So again, these spaces, you don't need them, but generally I like them because it makes it a little easier to read. But if you notice on every whole number, I put a decimal place, even though I didn't put like a 0.0 after it. So if you have just a whole number, on most machines, it's common to put that decimal, and some machines will even misread a whole number without that decimal. It'll think you're talking about 3/10,000ths of an inch instead of 3 inches. So you should always put a decimal on a whole number. So another thing we did here, we have a G0 on every line, and we actually don't need that. So it's called a modal code. So your G0, once you call it once, it still stays active all the way through until you replace it with another code from the same group. Ooh, we just talked about groups. Okay, so group 1, this is not every code that is part of group 1, but these are the common ones. So as we go through these videos, you'll see that if we replace if we call a G1, it cancels out our G0. And actually, when you turn on the machine, one code from every one of these groups is already active. So at any one time, there's always a code from each group active besides group 0, which is a different thing. Okay, so we we looked at G0. And then I put this here. There's a note, usually linear, but depends on machine. So there are some machines that will do something called a dogleg rapid. And that's if you have a kind of a diagonal rapid like this, where you're moving across two axes simultaneously, X and Y. Instead of doing this perfectly linear move, some machines will do what's called a dogleg. They turn on both of those motors to full rapid, which will actually give us more of like a 45-degree angle, and it will come over to here. And once the Y hits where it's going to, it stops, and then the X continues on. So you should just know about your machine, whether you're having true linear rapids or if you're doing dogleg rapids. And that can kind of get you in trouble sometimes especially if you're using CAM software or if you're using NC Viewer, where it looks like you're going straight line, but maybe there's something to collide with over here, and your machine will actually collide with that and get you in trouble. A lot of machines that do have dogleg rapids have a setting where you can change it to a true linear rapid too. So if you have that, I would search for that and see if you can change it back to a linear. Okay, so G1, linear traverse at feed rate. So we rapid to XY0 and then came down to Z0. What we can do is we can just switch this to G1 now. Oops, I need a capital. Let's see if I plot that. Ooh, see how the color changed to blue? So it's showing our linear moves as blue, which is helpful. One thing we're missing here, though, is a feed rate. So G0 is just at a full rapid of the machine. You can turn down your rapids on your machine generally, but assume it's going to be fast. So G1, we can set to a feed rate. So I'm just going to put like 20 for now. So that's 20 inches per minute. So that's just the rate that you're traveling through the material, or traveling through your motion, your tool path. Okay, so we have G0 and G1. So another thing to think about with all these is these are all called absolute moves. So that means any position here is relative to this position. So maybe instead of going to X0, Y0, we should go to like X3, Y negative 2. About that. So absolute just means every position here, each of these black dots is a position relative to your origin, not relative to where you are coming from, relative to this origin. So let's just look at, I'm going to jump a little ahead here, but we have absolute and incremental down here, these green ones. So we didn't specify G90 or G91, but it assumed we're in G90, that everything's absolute. And for the most part, you're going to be in G90. Just the way that most CNC programming is done is absolute movements. So I'm going to show you, you can do incremental moves. So let's say I do the next line. I'm going to do X1. And I'll plot this. So it came from this point to X1. absolute. So that means we're 1 inch to the right of our origin, which is here. But what if I had done a G91 instead of G90, which was active? I plot this. Ooh, it went 1 inch from the current location. So it's nice to know G90 and then G91. I'll do G90 X0, Y0. It's nice to know them, but as a beginner, it's easy to get in this mindset of G91 where everything is incremental and you're moving from this location out like a certain distance. So if you're having troubles with your program, that's another thing I would urge you to look at is, are you thinking in absolute or are you thinking in incremental? Because you should generally be thinking in absolute, not incremental. All right, so we're going to end this program or this video here and continue this series in the next video. Thanks for watching.